Here we're looking at the comparing strings file, and we're going to show how we can compare strings. Now, here is an easy example. Both are equal, P1 and P2, and we're using string compare, strcmp, with the two strings passed in, and this is going to either bring back a 0 if they're equal, like this case here, a 1 or -1. Let's look at the answers here in the output, comparing strings. And we can see here a little note about this function. It returns an integer and it takes two strings in as parameters. And like I said, if they're equal, then it's going to return 0. If the string 1 is greater than string 2, it's going to return a 1. So it deals in terms with the string 1 as compared to string 2. And then string 1 here, if it's less than string 2, expect -1. So that's how it's going to return. So the pendulum swings left to right depending on string 1's relationship to string 2 there. And you can also use other functions here. Substring and things like that. We'll take a peek at some of these here. String case is going to do the same thing here, except it's not going to be case sensitive. This string compare function is case sensitive. We'll take a peek at that as well. Ereg is dealing with regular expressions. So you want to see more about strings and then regular expressions for more information on that. And then we can just take a peek at the output there. So pass 1 and pass 2 are equal. If we make 1 a capital, for example, P1 is going to be capital now. So therefore, we should just refresh that. And then you can see that P1 and P2 are again compared. This is going to return -1. So according to our instructions, that means that a capital letter is going to be less than the lowercase a. In other words, the capital A comes before the lowercase a. It would make sense to come the other way. The lower letter isn't going to have as much weight as the uppercase, but when it does the string comparison, actually, the capital P has a lower value in that ASCII table than lower p. And that could be possibly different than what you might expect. Possibly. Here we have the ASCII character set. This is actually an ASCII chart. You can do a Google and find this. No problem, there are many different versions on the internet that have all different types of color coding and things like that. But this is going to represent your ASCII characters from 0 to 127 in this chart. And there are also additional 128 characters that go from 128 to 255. So the complete character set for ASCII is going to be 256 characters ranging from 0 to 255. Here we're only looking at the first 128. Just so we can get an idea of how this particular chart works. Well, you start here with 0. This is representing null, the character null. You also see that you have a bunch of words here. These are actually describing characters. You're only going to represent one character here, not words. Just one character. But these here, the first 32, they're not visible, but we still need to describe them. If you want to use the backspace character, for example, use the decimal equivalent, which is the integer value of 8. And we'll look at a special function called char, C-H-R. We'll take a look at that in a second. Or you can use the hex value to represent this, 0, 8. So this represents the backspace character. So use 8 with any function that requires the decimal value. You'll actually be doing a backspace there. You can do the same thing with tabbing or form feed. And very popular, the carriage return and line feed, which is very important. And that would be represented with CHR, or character 13, and character 10. So decimal is just representing an integer value. Hex is the hexadecimal value, which you may be familiar with in image editing when you're picking colors or with web design, and working with HTML or XML. Then the hex or decimal value represents that actual character. Now, when you think in terms of a space, SPC really doesn't represent space. It's really just saying SPC is representing the invisible space. So that decimal equivalent, the integer value, that's going to be 32. And that's very popular and important to know. But in our example, we use the capital letters and lowercase letters. Well, you can see here that capital A is represented by 65 decimal, and that's less than 97, which is the lowercase a. And this is a list here, all in order, all in alphabetical order, but it's really in the order that it was placed into the ASCII table. Now maybe you're familiar with Unicode. Unicode represents many character sets in one, And the ASCII character set here is quite limited. But you can see we can represent letters and numbers and special characters and punctuation quite nicely. In our example, we use the capital P and the lowercase p. Clearly, 80 is less than 112. No problem. So that's why capital P is going to be less than lowercase p when you do a comparison. Very important to keep that in mind. And again, you can do a Google search to find many different variations of the ASCII chart. Everything in the table is going to be the same, of course. You might look to understand the left-hand side here. 0 to 31 a little bit better, and I encourage you to take a peek at that. Many programming languages also have this ASCII chart in their documentation. So as we move forward, we can look at the CHR function, character function. Open paren, 32, decimal value, close paren. That's going to represent a space. If we look at the char of 65, that's a capital A. Char of 97, that's a lowercase value. So when you pass in that integer in between 0 and 255, you'll get back a character. The quotes here, they're just to signal that this is a character, a string. One character. You'll just get the A back. So therefore, capital A is going to be less than lowercase a based on our chart. The opposite is going to be the ORD function, which is going to take a character and return the integer value. ORD of A, in quotes, is going to return 65. So you can use this function throughout your programming with PHP as you wish, and just keep in mind the difference between the decimal and the characters. Decimal just means based on 10, like when you talk about hex based on 16 or octal based on 8. So the decimal number system. And this is how we normally represent our numbers. We're talking about integers here, 0 to 255. So let's get back to our example. A good thing is to convert your strings to lowercase or uppercase, or use the string case compare so you don't have to worry about case, because alphabetically it still would be the same, so you might want to use string case compare. So you see that the P1 here and P2 have different values. Pass 2 is going to be compared to pass 1, and then you can see that it's going to bring back a 1. And that means that string 1 is greater than string 2, and in that case 2 is going to come later than string 1, so it has a higher value in the ASCII table. And then the last one, we can see how that works. And I'm using P's because it's obvious that we can work with password comparison. And you can see that a comparison is going to be done here, and you can see that this is going to extend out, and you can see the answer there is going to return a number -1, meaning that the string 1 is going to be less than string 2. And as you can see, that's what the case is here. Now, a normal thing you're going to use is use string compare when you want to compare things like passwords. And passwords are case sensitive, so you're not really concerned with the fact that one is greater than the other one, but you're concerned with whether or not the passwords are the same. So that's something that you can do. And check to see if they're 0. And then you can see on the bottom, P1 and P2 are not the same. And then the other comparison, checking for just straight equality, we have the double equal sign, and that does work as well. And it shows that they're not equal as we compare these two here. If we change the two to make them equal and refreshed, now we're getting the same response that they're both equal. And we're getting a 0 response here as well to say that they're equal. So that changes things around. So that's how you could check for equality with passwords. Either way, with a double equal sign there, it's no problem.